Machine learning is a technique in which you can use data to train a model that predicts unknown information. For example, suppose a bicycle rental company keeps records that include the weather conditions, temperature, and seasonal details for the days on which they've operated. And they also record the number of bicycle rentals that they had each day. The weather and seasonal characteristics for each day are called its features, and the thing that we want to train a model to predict, in this case the number of rentals, is called the label. For short, we often refer to the features as X and the label as Y. We can take this historic data and apply an algorithm to figure out a function that fits the features to the label. In other words, the function calculates Y from X. The function we've calculated is the basis for your predictive model. So if you have the features for a new day, but the label is unknown, you can use the model to predict the unknown label, which in this case is the expected number of bike rentals. This kind of machine learning, where the label your model predicts is a numeric value, is called regression. Now let's look at another form of machine learning. This time, suppose a health clinic takes measurements from patients, including blood pressure, glucose level, weight, height, and so on. Additionally, each patient is categorized as diabetic or not diabetic. The patient measurements are our features, or X, and the classification of diabetic or not is our label, or Y. We can fit the features and labels to a function that calculates the probability of a patient belonging to a particular class based on their features. In this case, the possible classes are diabetic and not diabetic. When the features for a new patient are collected, the model we've trained can predict the probability that the patient is diabetic or not. This kind of machine learning, where the predicted label is a category or class, is called classification. So far, we've seen examples of regression, where we use historic data to train a model to predict a numeric value, and classification, where the model predicts the class to which an item belongs. These are both examples of supervised machine learning, where we have historic data with known feature and label values that we can fit to a function to train the model. Now suppose you have data that consists of features, like the measurements and petal counts of some flowers, but you have no known labels. You just want to group your items together into clusters based on their similarity. In this case, the flower measurements are our X value, and the Y value represents the clusters into which we want to group the flowers. We can use an algorithm to separate the data values into clusters based purely on the feature values, and the resulting model predicts which cluster each flower is assigned to. Clustering models like this, that are trained without a known label value, are examples of unsupervised machine learning. Regardless of the kind of machine learning model you want to create, there's a typical process that you follow. First, you need to get the data with which you're going to train your model. We call this data ingestion. Then there's usually an iterative process in which you explore the data and prepare it for modeling. Data pre-processing includes steps such as feature selection. In other words, identifying features that are likely to help predict the label and discarding others. Then you might clean the data, for example by finding outliers or errors and removing them, and imputing missing feature values with a suitable replacement. You might also engage in some feature engineering to derive new features from existing ones. And you should generally normalize your numeric features so they're on the same scale. Then you can apply an algorithm to fit your prepared data and train a model, and evaluate its performance. When you're happy with the model, you typically deploy it to a service. Applications can then connect to your service and use it to predict unknown labels from known feature values.